Hi everybody, my name is Alex Palesandro.
And I am Mattia Lavacca.
Today we present you Liqo, a new open source project. Liqo enables resource sharing across different Kubernetes clusters, and it wants to support multiple features. Decentralized governance, for example, but also geographically sparse clusters and cost optimization. Let's start with a demo.
In this first demo, we will create two different Kubernetes clusters. We will install Liqo on both of them, and we'll deploy a complex microservice-based application. Some microservices will be executed in the first cluster, and some others in the second one. Finally, we'll check that the application will be completely working and that the microservices will be distributed among the two different clusters. As a first step, we are going to create two different Kubernetes clusters with kind. Each of them will have two physical nodes. Once the clusters are ready, we will install Liqo. The two Liqo instances are able to discover each other and to share computational resources among different clusters. No further configuration is needed to make the system completely working, so we use vanilla Kubernetes.
So now let's install Liqo on both clusters. As you can see, the installation process of Liqo is very simple. You only have to get the installation script and execute it. The installation script is able to detect the network configuration of your clusters. In particular, it detects the service side and the pod side. It also elects a gateway node. A gateway node in Liqo is responsible to interconnect your cluster with the other ones.
Now we have to wait for the control plane to be ready. Liqo control plane has a bunch of components that allows communicating with the other cluster, to share computational resources and to create a proper network configuration. We are expected to see a node creation in both clusters. This node is a virtual node, implemented by means of our custom version of the virtual kubelet. This virtual node masquerades a whole remote cluster by offloading to it all the new received pods and handling their entire life cycle. We don't need to apply any modification to cloud-native applications for making them compliant with Liqo. Once we create a new namespace, we only need to label that namespace for communicating to Liqo control plane that the pods in that namespace are eligible to be offloaded.
Now we deploy a cloud-native application made by Google. This application is composed of several microservices, and those microservices are communicating via the Kubernetes services. Some of them will be scheduled on the first cluster, and some others will be scheduled transparently on the second cluster.
Along with the remote pod offloading, some Kubernetes resources are replicated remotely. The services used by the website are recreated, as well as the endpoint slices needed to implement pod-to-pod and pod-to-service communication. It works even in case of overlapped pod siders, for being fully compliant with Kubernetes. At the end of the day, Liqo makes the whole application work independently from the scheduler decisions. Let's suppose that we want to provide high availability. So we can simply scale up our deployments, and the scheduler will select the best place for each pod to be executed, depending on the amount of available resources. Obviously, if you run out resources locally, Kubernetes may transparently use the remote ones. If we delete some pods, for example by scaling down the deployment, the offloaded pods are correctly deleted and the resources needed to implement the cross-cluster communication are deleted as well.
Okay, the demo is over, so thank you very much for your attention. You will find our project on GitHub, it's liqotech/liqo. If you like the project or this demo, you can leave us a star. And so you will find also in the description of this video all the important links about this project. Thank you again and see you next time.
Bye!